Yeah, hello.
Hello. Ramit, can you hear me? Because I can't hear you.
Yeah, I can't hear you. Yeah.
Yeah, okay, fine. I can hear you now. Okay. Fine. So, what were we doing last class?
I can't remember. It was like 2 weeks ago.
2 weeks ago. We were still doing amines, I guess, right?
Yeah.
Okay. And what in amines were we doing? Any idea about that?
Actually, can't remember because it was so long ago.
You must have your book with you.
Let me look. I'm just having a look at the notes. Just give me like 2 minutes.
Yes, okay, fine.
Yeah, so in my notes, the last thing we're doing like reactions with ammonia for nitros, the production of nitros, and all that.
Okay.
There's uses of amines, and yeah, we're just doing all that.
So lastly, what we were doing, I think we were talking about the reactions of amines. One we saw
Yeah.
dilute mineral acids, right? If I'm not mistaken. And second, we did comparisons of the base from primary aliphatic amines to ammonia to primary aromatic amines. And I think I gave you a few questions to solve it, right? I think we ended up over there.
I think so, yeah.
Yes,
Yeah.
yes. Okay, fine. So today what are we going to see is, we are going to see about the nucleophilic properties of amines.
All right. Nucleophilic properties.
Okay. You must have a
Yep.
idea of what nucleophilic reactions are, right? I think we
Yeah.
saw them early also.
Yep.
For a revision purpose, nucleophiles are the lone pair donors.
Yeah.
Okay, they are the lone pair donors. So now all amines, they contain the lone pair of electrons on the nitrogen atom.
Yeah.
Okay, so they act as a nucleophile. Now these nitrogen, they act as a nucleophile. Okay.
Yeah.
Now we'll start with various reactions. First reaction we are going to see is nucleophilic substitution reaction with halogenoalkanes.
Yeah.
Okay, what is a halogenoalkane?
Just an alkane with a halogen.
Halogen along with an alkane group.
Yeah.
Okay. Now the
Yeah.
reaction of a halogenoalkane with a ammonia or amine, what do they form is, they form either primary, secondary, tertiary, or a quaternary amine. So
Yeah.
we're going to see one example of all of them. Okay. First,
Yeah.
we are going to see how a primary amine is being formed. Now, primary amine, a simple halogenoalkane we are going to take. That is CH3CH2Br. What is the name of this compound here?
CH2, CH3. So that's bromomethane.
Bromoethane. Okay. Now,
Yeah.
bromoethane with ammonia.
Yeah.
Give me, what is this? This is a substitution reaction.
Substitution. Yeah.
They are just getting substituted. Okay.
Yeah.
It is CH3, CH2, NH3Br. Okay. Now,
Yeah.
for primary amine, this is the reaction is happening in 2 stages. Okay. This
Yeah.
is my first stage where I am getting ethyl ammonium bromide. Right? What I'm getting,
Yeah.
ethyl ammonium bromide. Okay, I have formed one product over here. Now, this, when the excess of salt is going to react with excess of ammonia, okay,
Yeah.
what is happening is, in the mixture, they remove this one of the hydrogen ion and they form a primary amine. So, we are going to use the same product to form the proper amine, okay. So, how this reaction will be, CH3, CH2, NH3Br. Okay, I am using ethyl ammonium bromide again with ammonia.
Yeah.
It is a reversible process where I am getting CH3, CH2, NH2 plus NH4Br. Here I am getting my proper primary amine, that is ethyl amine.
Okay.
Okay, you understood how it is happening?
Yeah.
2 steps.
Yeah, I got that. Yeah.
Always
Yeah, it's
say-
just substitution reaction. That's all.
Yes.
Yeah.
Whenever there is a reaction of amine, first we won't be getting the amine directly, right?
Yeah.
We have to undergo 2-step process. Now this is only applicable for amines only. Okay, so here I
Yeah.
found my primary amine, that is ethyl amine. Now second, we are going to form a secondary amine. Again, we are going to undergo substitution reaction here, okay, because now we are going to use is a primary amine again. Okay,
Yeah.
now let's see how is this happening. Again, 2 steps reaction. I have my simple halogenoalkane plus
Yeah.
what I'm going to take is my primary amine here, that is CH3, CH2, NH2, giving me CH3, CH2 twice, NH2, Br. You understanding what I've done? Again, I have
Yeah.
halogenoalkane, but this time to form a secondary amine, I am using my primary amine, ethyl amine I am using here. Okay, and I've
Yeah.
a product. Now, what is this product? This is nothing but diethyl ammonium bromide. Okay, so
Yeah.
I got a product which is diethyl ammonium bromide. Now, what do we
Yeah.
want? We want a secondary amine.
Secondary. Yeah. Secondary. I mean.
Again, using the same dimethylamine, let us form a secondary methyl. CH3, CH2, NH2 Br
Yeah.
plus NH3 giving me CH3 CH2 twice NH plus giving me NH4
Yep.
Br. Okay. Now here I have got is my diethyl amine, which is my secondary amine.
Yeah.
Okay. So you understood how have you got primary amine and
Yeah, I got that.
amine? Yes. Okay.
Yeah, I'll just make a note now. Yeah. Yeah.
Yes, you write it down. Just remember, whenever we are making amine, we always have a two-step process. And
Okay.
whenever we are making a secondary amine, we are using my primary amine inside my secondary amine.
Yeah.
Okay, note it down.
Chapter.
So you understood what's happening over here?
Yeah.
Moving on. So we have seen primary and secondary. Okay. Now we are going to make a tertiary amine. So you tell me, for making a tertiary amine, what do you require?
If we're making a test for it, amen. So that was sec. Just give me a
For
minute.
making primary amine, what did we do? And for making a secondary amine, what did we do?
So for the first one, is this a normal halogen alkane plus a or just
With,
give me
we
one sec.
reacted them with ammonia, simple ammonia, right?
Yeah. Yeah.
Got an ammonium salt, and with along that, what did we see? That we reacted an ammonia with excess ammonia and we got primary amine. And to make a secondary amine, we reacted the same primary amine with the secondary amine. Now to make a tertiary amine, what do we need? We
mix the secondary
amine. So, but initially we should always start, we should always start with the primary amine, okay? That is not primary amine with the halogenoalkene.
Yeah.
CH3, CH2, Br. I am just using the constant halogen which I am using from the beginning. Okay.
Yeah.
Plus, now my secondary amine was diethyl amine, right?
Yeah.
CH3, CH2, twice, NH, giving me CH3, CH2, thrice, NHBr. Okay, you understood
Yeah.
what's happening? Just a substitution reaction.
Yeah.
Same kind of substitution reaction. Now I'm going to use the same. Earlier I got was diethylamine. Now I have got as a trimethylamine, right?
All right. Okay.
Now I'm going to use this again. Sorry, triethyl ammonium bromide. This is triethyl ammonium bromide. Okay, now I'm using this triethyl ammonium bromide with excess of ammonia.
All right.
Reversible reaction, what am I getting is CH3, CH2, thrice N plus NH4Br. Now this is nothing but triethyl amine. You understood what is happening over here? Same formula. Now we have got tertiary. Let's make it into a quaternary ammonium salt.
Yeah. Then you make the quaternary ammonium salt. Yeah.
Yes, we will stop here in quaternary ammonium salt. Okay. We started with primary. So again, now we are going to react with the tertiary amine. Yes.
Yeah.
Now, if you see, since the quaternary ammonium salt cannot act as a nucleophile, we will have only one step process.
Yeah.
That is CH3, CH2, Br plus CH3, CH2, thrice N gives you CH3, CH2 times 4 NBr. This is nothing but quaternary ammonium salt.
Yeah.
Okay, what is this? This is quaternary
Quaternary ammonium.
salt. So this is just one step process.
But just a one-step process to make that.
Sorry?
Yes, it's just a one-step process to make
This
the
is a
quaternary.
one-step process because all the other steps were going nucleophilic substitution. Here, direct process, right? Because
Yeah.
there is no longer a lone pair of nitrogen available. Here,
All right.
the lone pair of nitrogen. Therefore, now we have only one pair. So it is going to form a quaternary ammonium salt.
Yeah.
Okay, write this and then we'll go on to the next small subtopic.
Okay. Yeah, I'm just writing down the last bit. One sec.
Write it and then tell me. Okay. So we just saw something. I mean, we have seen a process wherein from primary amine till quaternary amine, we have seen how they are being produced. Right?
Yeah.
Now, what are the conditions under which they are being produced? We are going to see that. Okay. Now, in this reaction, all the reactions I'm talking about, okay, starting from my primary amine to my
You
quaternary.
have to be an excess ammonia. Yeah.
Repeated nucleophilic substitution is happening, right?
Yeah.
Repeatedly the substitution reactions is happening till we get the quaternary ammonium salt.
Yeah.
So we are going to see how these are act as a starting material to the electron donating alkyl groups. So it will be somewhat this way. This is an alkyl group, nitrogen, okay, halogen of
Yeah.
bromine. This is going to give me now this is nothing but my primary amine. Then what I'm getting is my secondary amine. Plus bromine. So finally, what are we getting is a quaternary amine. Okay. This is in short how are we getting this nucleophilic substitution reaction. That is a successive, I could say it is a successive substitutions of the amine group. Okay. So initial reactions, what we say, excess of ammonia is favoring, right? Starting from the primary amine to the secondary, then excess of alkenes, they are favoring for the formation of the last quaternary ammonium salt. Okay.
All right.
You understood this part, how it is happening?
Please repeat it quickly again.
No, I just said this is the simplest form of how I could explain to substitution reaction. Okay?
Okay, yeah.
Oh, right.
Yeah, we can move on now, yeah.
You're done?
Yep.
Okay. Moving ahead. Okay, so we saw few uses and properties of amines, right? But we have not seen uses of quaternary ammonium salt. So we'll see that.
I think it was like bactericide, wasn't it? Or things like that.
Bacteria?
Yeah? Is that right? Bactericide.
Bacteria cell.
No, but bactericide, so like the removal of bacteria. So.
Okay, so we'll see that. Earlier, can you tell me one property or one use of ammonia which we see primary, secondary, tertiary?
Well, the bleach.
Dyes, right? You remember they were used as dyes?
Oh, dyes. Yeah.
Dyes. They were used as in the production of dyes. Now, quaternary ammonium salts are used in the production of cationic surfactants. That means the detergents, okay, fabric softener,
yeah,
Then we have hair conditioners.
Yeah.
Okay. So now this quaternary ammonium salts are used for the production of detergents, fabric softeners, hair conditioners, and many more things. What
Yeah.
do they do? What is the use of a fabric softener and hair conditioner? What is the similarity in both of them?
Um. Oh, one sec. Can you just repeat the question again, please?
Some common factor between a fabric softener and a hair conditioner.
Yeah, well, about the yes, it's about soften the
Okay, both of them are just coating down, right, on the surface.
yeah,
For the
yeah, that's it.
detergents is okay, they are washing away, right? But when I'm comparing fabric softener with hair conditioner, we know that they are just coating the surface of the cloth here and the surface of the hair over.
Yeah.
Okay, and they also reduce the static energy over here. Okay,
Yeah.
so this is a simple use of a quaternary ammonium salt.
Yeah.
Now we'll see is we just saw nucleophilic substitution. We'll see the mechanism of nucleophilic substitution. Okay, mechanism of the nucleophilic substitution reaction. So we will
Yeah.
take one reaction at a time. That means from a primary to a secondary to a quaternary. Okay.
Yeah.
So it will start with like this. CH3 CH2Br plus 2NH3 giving me CH3 CH2 NH2 plus NH4 Br. Now what is this? We have bromoethane, we have
Yep.
ammonia, we have
Yep.
ethyl amine. Ethyl amine comes under which primary, which amine group?
That's the first degree, isn't it?
Primary amine group, right?
Yeah.
Okay.
Yeah.
So this is a simple primary amine group. Now we are going to see how the mechanism is happening over here. So we have CCH, H, 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 and Br. Okay. Now 2NH3. This I can put it down here because this contains a nucleophilic substitution, right?
Yeah.
NH3. Now this is undergoing to form ethyl amine. Now what is happening here is this lone pairs of electrons, they are going to move with this carbon, okay? And this bond is going to shift over to the bromine one. And what do I get over here is CCH, H, H. Now bromine has the lone pairs of electrons.
Yeah.
Right? And if I had to add one more pair of this nitrogen atoms, it will be this way. So this is going to join with this hydrogen atom. This bond will go and join with this nitrogen. Fine.
Yep.
And what will I have is So have we got methylamine at the end after
Yeah.
nucleophilic substitution? What is happening here?
Once I'm just writing down the reaction.
But did you understand the concept over here? How the sun you make?
Yeah, I did. Yeah.
Okay, fine.
It's all in excess ammonia, isn't it? So everything is in excess. So we'll just continue reacting with it, and then.
This is the mechanism. We have not yet done with the mechanism. We have just seen the primary part.
Yeah. Yeah, I'm done. Yeah.
Done?
Yep.
Okay, so this was a mechanism of my primary amine group. Okay.
Yep.
After primary comes my secondary amine. So we'll see how the further substitution is happening over here. I mean the mechanism part. I have my halogenoalkene.
Yep.
I have my lone pair of ammonia. Okay, I'll tell you what is happening over here. So this lone pair is again going and shifting it with carbon, and this bond is coming and getting attached to bromine.
Yeah.
This is very similar to that of the primary one. Okay,
Yeah.
concept is very much similar. Okay, what do we form here is the diethyl
Yep.
amine. Okay, then I'll write down the mechanism for the quaternary ammonium salt also. Okay, that way our mechanism will be over. Okay, Put it down and then tell me. Okay. So you understood whatever we have done till today? I mean the whole concept
Yeah.
of what did we start with? The nucleophilic substitution reaction.
Yeah, the whole nucleophilic, yeah.
Sure, damn sure.
Yep.
Okay. And I think this is the end of amines.
All right.
Okay, so we have completed with amines chapter completely.
Okay.
Now go through entire chapter of amines, whatever you have any doubts, wherever you have any doubts, and ask me. Till the
Okay.
time, I'll be writing few questions that will be for your homework for next class.
Okay.
Be prepared with that questions, and next class I'm going to give you a test on the entire chapter of amines.
Okay.
Okay?
Yep.
Just go through it and let me see if you can answer some of the questions over here.
Okay. Let me look for it.
Okay, this will do.
Okay. I can't think of any questions. Yeah, I'll just revise these then for the next test.
Okay, fine, no issues. But next class, you have a test on the entire chapter.
Okay.
Okay, be well prepared with that. Fine.
Yeah.
That progress report is going to your father.
Okay.
Okay. Okay.
Yep.
Meet you in the next class. Bye.
Goodbye.
You are currently the only person in this conference.